So you want to know everything. To do so, you will need the theory of everything, which explains the four fundamental forces of nature, the strong, weak, electromagnetic, and gravitational force, under one umbrella. However, the current theories attempting to explain these fundamental forces, quantum mechanics and general relativity, are completely incompatible. One reason why is that quantum mechanics, as the name suggests, describes quantized forces, meaning that their energies are discrete, with nothing in between the allowed energies. It's like the number of people in a group. You can have 1, 2, 3, etc., but not 1/2. On the other hand, general relativity describes continuous forces. It's like the number line. You can pick any decimal between 0 and 1. The force could be any number you want it to be. Another reason is that quantum mechanics relies on particles to explain forces. This makes sense because a particle is quantized. It's like the number of people in a group. How does a particle transmit a force? Think about it this way. This ball represents a particle. When I throw this ball to another person, there's a repelling force as we are both pushed away from each other. The exchange of the particle causes the force. On the other hand, general relativity relies on the bending of the fabric of space to explain forces, where this fabric is continuous like a number line. How does the bending cause forces? Well, pretend this tarpon piece of paper is the fabric of space that all objects are in. You can imagine if you have a heavy object on it, this fabric will bend down where the heavy object was, and objects placed near it will fall towards the heavy object. An attractive force is seen by the bending of the fabric of space. So obviously, these two theories are contradictory. It can't both be true at the same time. You can't add a discrete particle to a continuous space. Indeed, experiments have shown that all the forces but gravity can be quantized, supporting quantum mechanics. Gravity, on the other hand, can only be explained with general relativity. Thus, we don't have one unified theory. How do we try to incorporate gravity with the other forces? Well, if we keep thinking in our 3 dimensions of space, we are stuck. We have to quite literally think outside the box. Imagine you live in one dimension and see these seemingly random colors. It's very hard to explain one dimension, but if we increase the dimensions and look at it from 2, then all the colors make sense. We are able to gain more information by looking at a higher dimension. Sure enough, through looking at 11 dimensions, quantum mechanics and general relativity are unified in something called string theory. String theory proposes that if you zoom in enough at anything, you will see the same fundamental thing, connected strings of energy, which look kind of like a necklace. Like a violin string, these strings vibrate at different frequencies, but rather than playing different notes, each frequency is a different particle that produces a different force. The strong, weak, electromagnetic, and even gravity are all made of these strings. Finally, all the forces of nature can be explained under one theory, and we have found the theory of everything. Except we haven't. String theory is still just a theory, and many parts of it still remains unclear. It's up to our generation to explain everything.